So this is a second part of direct proportion lesson 4. So for this part, we are going to talk about how could we find an algebraic expression for a linear relation. We have learned that for a direct proportion, you see when a straight line passes through the origin, then we will say y directly proportional to x, alright? And you could write y equals kx, alright? K is a constant. So how about for linear but not direct proportion, because the line is a straight line but it does not pass through the origin? So in this case, the expression is quite similar. It's also like y equals something times x, but this time you need to add a constant c, okay? And this c would be a non-zero, okay? So for an equation like this would be an algebraic representation for a linear relation. So for direct proportion, the algebraic representation will be y equals a number times x. For linear but not direct proportion, we will see y equals a number times x plus a non-zero constant. Okay. The problem is, how could we find the value of this m and this c? So here are the rules. If there is a linear relation between x and y, then we could write y equals mx plus c, and m would be equals change in y divided by change in x, or you might use the notation like this. This is the change in y over change in x, which we have seen that before in our part 1 video. And c can be found by the value of y when x equals 0. Okay. So c is the value when for y when x equals to 0. Alright, so let's see how could we do it. So the question is, establish an algebraic relation for each of the following linear relation between x and y. Okay, so we need to have an algebraic representation. Still remember how to do it? So first we have x and y, but we're more interested in delta x and delta y, okay? So for example, from 0 to 1, x increased by 1 and y is increased by 2. So delta y over delta x will be 2, right? Right, so you might see others, but they will be the same. Okay, so it's also 2, right? 2 over 1. So we are not going to track everyone, because the purpose of this question is not to confirm the linearity of between two variables. You don't need to show that they are linear. Okay, so after we find delta y over delta x equal to 2, this will be our value for m. Okay, let's write m equals delta y over delta x equals 2. So how about c? Remember, c can be found by the value of y when x equals 0. So when x equals 0, y is 3. Okay, so you see here, when x is 0, y is 3. So we will have c equal to 3. So therefore, we will have y equals to x plus 3. Okay, But how do we know this is correct? So this will be the answer. So that's it. But how can we know this is the answer? So in the examination, to make sure you got the correct answer, you need to do some checking. Okay, how can we do the checking? Possibly we're going to use last pair of data. So you will have x equal to 4, y equal to 11. So let's see, could we see when x equal to 4, could we see that y is really 11? Okay, so we put that 4 into our equation 2x plus 3, and you will have 2 times 4 plus 3. Okay, you need to put that x value into the equation to see whether y is really 11. So you see x equals 4, then y equals 11. So they agree with the data in the table, right? So that means the equation is right. Okay, it is correct. Okay, so in the examination, it's not necessarily for you to show your tracking, but it's a very good habit to track the answer by other pair of data to see whether you got the answer, right? Okay, so let's find another algebraic representation for this pattern. Alright, so for this pattern, again we will have delta x and delta y. Okay, so you see plus 2 is plus 6. Alright, so that means our m, which is delta y over delta x, will be 6 over 2 equals 3, right? Of course, if you want to check one more, it's okay. So see the pattern, this is a linear pattern. So how about C? Okay, do we have x equals 0? Yes. When x equals 0, y equals 5. So we will have c equals 5. Right? So therefore, we will have an equation y equals x plus 5. And of course, we would like to have a track to see if we really got the answer. Let's use the last pair of data to do the tracking. So for the tracking, we know x equals 6, y equals 3 times 6 plus 5. What number do we have? 23. So it actually agrees with the given data. So we know it is correct for our tracking. Okay, good. Okay, let's do another two. So this time, again, you are provided a table, right? So here is plus 1, here is plus 4. Okay, so sorry, I forgot to write that's delta x, delta y. Okay, so you see, it's plus 1, plus 4. All right. Okay, so m delta y over delta x equals 4 over 1. Okay, so to confirm that, you might see if that pattern continues. Yes, so that means it's a linear pattern without any doubt. And also you see that it's always, when you use delta y over delta x, you always give you 4. How about the value c? Okay, so here's the problem. Because we don't have a value, we don't have a 0 in the table for x, there's no 0 when you compare to our previous question. In our previous question, you see there's a particular value which is 0 and y is 3. Okay, and so let's look back here. So by here we don't have such value, but we could make some deductions from the value we already have to see what should be the case when x is 0. Okay, what would be our y? Okay, so when x is 0, from 1 to 0, you need to take 1, right? You need to take 1. From 1 to 0, you need to take 1. So when we look at when delta x is plus 1, delta y will be plus 4. So how about when delta x is minus 1, then naturally you would think delta y should be minus 4, right? Okay, I say it again. So how could we know it's minus 4? It's because when we look at the given data, from whenever x is increased by 1, y will be increased by 4. So now, in another direction, when x is decreased by 1, what will happen to y? Y will be decreased by 4, right? So should be 1 here. Alright, so that means for this pair of values, 0, 1, so we will have c equals 1, because when x equals 0, y equals 1. Alright, so therefore we will have y equals 4x plus 1. Okay, so to make sure we get the correct answer, we use the last pair of data to do a little bit of tracking. Okay, so when x equals 4, we will have y equals 4 times 4 plus 1, which is 17. So it agrees with the data given. So we know it is correct. Alright, so the following is one more example. So you might do that, okay, by your own and come back to track the answer. Now please pause the video. Okay, so here's the answer. This time there's a little bit difference. When you see delta x is not always plus 2, so we have plus 2 and plus 1. And when you see delta y is not always plus 8, you got plus 8 and plus 4. But remember, m is a ratio between delta y and delta x. So when you use delta y divided by delta x, you could use 8 divided by 2 or 4 divided by 1. Both will give you the answer 4. So that will be good, right? So to find the value of c, you need to go back from 1 to 0. That means you need to take 1 from x. Then, since when you add 1 to x, you need to add 4 to the y. So now when you take 1 from x, that means you need to take 4 from y when y is 0. Okay, so the pair of value will be when x 0, y equals minus 4. So that's why c equals minus 4. And your equation will be for x minus 4. And you can do the tracking as well, and it will give you 20, okay, when you put x equals 6. So you'll get the answer. Alright, okay, not the most difficult one. Alright, let's see a pattern. So we use 3 stick or looks like match, right? Okay, anyway. Alright, so you see when they are going to form one triangle, they use 3 matchsticks. Okay, when they are going to form 2 triangles, they use how many? 5 of them, not 6, 5 of them, but that's one side which is common. When they are going to form 3 triangles, they use 7 matchsticks. And when they have 4 triangles, they use 9. So the question is, how many matchsticks you are going to use for 10 for 10 triangles? How many matchsticks does it need? Alright, okay, so let's find the algebraic rule between x and y first. Then we could answer the question how many matchsticks will be required for 10 triangles. Okay, so let's see if this is really a linear pattern, okay, you plus 1. So it seems delta x is always plus 1, plus 1. And of course, and here is plus 6, right? Okay, but we check the number we've already provided. So for those number already provided, they are always increased by 2. Alright? So when x is increased by 1, y is increased by 2. Okay, so that's delta y. Alright, so basically you could find m by using delta y for delta x, which is 2 divided by 1, which is 2. Good. Then we are looking for the value of c. C will be the value when x equals 0. Okay, so let's put 0 here. How about y? Okay, let's go back. Okay, from 1 to 0, we have to take 1 away from 1. Okay, so how much should I take away from 3? Remember, whenever you add 1 to x, actually you will add 2 to y. Okay, so that means if you take 1 from x, you have to take 2 from y. So 3 take 2 becomes 1. Okay, so that means c is 1. Alright, okay, let's see. So we have a relation y equals to x plus 1. Of course, we need to track. So we use 4, 9 to do our tracking. Always do the tracking. Okay, when x equals 4, y equals 2 times 4 plus 1. Is it really 9? Yes. Okay, so it is correct. Okay, so now we are quite happy with our algebraic expression because you can satisfy all the data provided. But how about the last one? So let's say when x equals to 10, what would be a value? What would be a value for y? Okay, so it should be 2 times 10 plus 1. Okay, so it should be 21. So it takes 21 matchstick. Okay, could you imagine that? Okay, alright, so okay, of course there's another way to do it. So another way is, whenever you add 1, you add 1 to x, you add 2 to y. So that's another way to do it. When you add 6 to x, that means you need to add 2 times 6, that means 12. When 9 plus 12 is actually 21. So that's another way to do it. But since we've already got the algebraic rule, so I think that would be easier for us to do it. Okay, so here are some practice for you to try to do. There are several questions we have done. You need to use double line method to check whether it's direct proportion. Remember, the method we use to check direct proportion is different to the method we use to check whether two variables are in linear direction, are in linear relation. Okay, so that's another way to do checking for linear relation. Okay, so if you have some doubts, do go back to see part 1 in this for this video. Alright, so and the third question is about how could we establish an algebraic rule for the linear relation. Alright, so you got all the answers just below the questions. Just try to do them. Don't just copy the things from the video. I understand it's quite a lot of work for some of you, but remember that you have such a good potential to do more. So for better learning, you need to try something by yourself. Okay, which means you need to do some question in the practice to see whether you really understand the content. All right. Okay. See you next time.